In this video, we will be talking about exponents, the laws of exponents. And as you can see here, basically we have 8 of them. In some books, they wouldn't consider the 8th law of exponent, which is basically the exponent of 1, because it's quite obvious. But in consideration to learning it all, we'll be having 8 laws this time, including the exponent of 1. Without further ado, we will be starting with the distributive law over multiplication. Now, for the distributive law over multiplication, our basic formula is x, any number multiplied to another number, xy, that is in parentheses, both of these numbers inside a parenthesis, this raised to any exponent. And because it's called distributive law, that means it concerns, even this law over division, these two laws concern the use of what we call distributive property. There. Basically, just to recall, distributive property is, in this case, we distribute the exponent to the bases of this expression. So it will be equal to x raised to m times y raised to m. So this is our final answer. For example, if we use x equal to any number, say 9, times any number y would, let's say 5, times the parenthesis, times the square root, sorry, not square root, any exponent m, let's say 2. So 4 times 5, everything raised to 2. This means we'll have 4 raised to 2 times 5 raised to 2. And with this, we'll just have to simplify. 4 times 4 is equal to 16. 5 times 5 is equal to 25. And if we multiply 16 and 25, the number is quite big, so we'll be using a calculator. But it still depends, according to the school that you are at. If your teacher allows you to use a calculator in solving such large problems. So our answer would be 400. Now, moving on, we have the distributive law over division. It also uses distributive property, and our formula for this would be y over x, any number over another number, all times the exponent of any value of exponent. So, example, we have 1 over 2 times the exponent of 2. In this formula, what we'll get, basically, we'll distribute the exponent, so we'll get y raised to m over x raised to m. That's our final answer. Now, in this example, basically we'll have to say our numerator is equal to 1 raised to 2 over 2 raised to 2. There. And after following this exponential law, we'll have to finalize our answer. So 1 times 1 is equal to 1 over 2 times 2 is equal to 4. And that is our final answer. Moving on. For our exponent of 0, basically, our formula is any number, let's consider that as x, raised to 0 would always be equal to 1. Any number that is raised to 0 is equal to 1. Example, 4 raised to 0, that will be equal to 1. Usually, the mistake of students here is that whenever they see an exponent of 0, they consider the base as 0. So example, 4 raised to 0 is equal to 0. This is wrong. We'll have to take note of this, okay? And another example, 51 raised to 0. That will be equal to 1. That's it for the exponent of 0. Now, for the exponent of 1, any number, let's consider that x again, raised to 1 would be equal to that same value of what x is formerly. In other words, we'll have an example. 4 raised to 1, that would be equal to 4. So the number doesn't change, the base does not change. Example again, 49 raised to 1, that would be 49. Moving on. We'll have our product rule. So basically, product rule says that any x, any number raised to a, exponent of a, times another x, the same number as this one, raised to b, would always equal to x raised to a plus b. So we'll just have to remember that the product rule is multiplication. And in this case, if they are multiplied, the exponent's operation would be addition, a plus sign. Sorry, I made it not look like a plus sign, but that's a plus sign. Example, we'll have x as 8, and our exponent a would be 2, and another 8 because we have another x here. Then the exponent b will be 3. So 8 squared times 8 cubed. Basically, that would be, we can say that 8 raised to 2 plus 3. And after this, furthermore, we could say that this will be 8 raised to 5. And that concludes us to our solving with the calculator. So 8 raised to 5 is equal to 32,768. So the answer is quite crazy because we already know that this number is quite high. Let's have a lower number. Still using this formula, product rule. Let's have 2. Our exponent a is still 2, but let's change our exponent b. We'll have 4. So again, we'll have to place 2 raised to 2 plus 4. And furthermore, this will be 2 raised to 6. Sorry, that was a mistake. 2 raised to 6. If we calculate that, we will have 64. So this will be, you will multiply 2 6 times. So 2 times 2 times 2 times 2 times 2 times 2. We have 64. That's basically just it. Now, for our quotient rule, it's quite the opposite of that of the product rule, because the formula, it's not really too far. X raised to a over y raised to b. This will be equal to x raised to a minus y raised to b. There you go. It's a mistake. I apologize. That was a mistake also. For quotient rule and product rule, we'll just have one specific base, and we'll just describe it as x. So for quotient rule, our formula is x raised to a over x raised to b. That will be equal to x raised to a minus b. And if you can observe, the sign here is a minus. On the contrary, our sign here is addition. These rules are contrary to one another, but they are similar in terms of product rule, quotient rule. They're similar terms. Quotient rule because this one is division. Product rule because this one is multiplication. And furthermore, we can say that the analogy, just to remember for our exams, the product rule consists of the multiplication sign, and it has an addition sign for the exponents. On the contrary, quotient rule consists of a division sign, while the exponent has a subtraction sign. So that's just it. You can use your other technique, but again, this is just a specified technique that I improvised. And just to say, it helped me get my way through my exams. Now, for the next law, we have our power rule. Our power rule, basically, we have a formula of x raised to a times b. B is an exponent here, okay? So if we have that, basically, this is x raised to a b. Nothing really too serious, which is, in this kind of formula, we have a inside and we have b as an exponent outside, so just have to use distributive property, distribute exponent b to exponent a, and voila, we have x raised to a times the exponent of b. So we'll have an example. Let x equal to 5, and exponent a will be 2, exponent b will be 3. And just to tell you, why am I trying to make the exponent values low? That's because we don't want to have really high numbers in our tutorial video. This is just to show examples, and nothing really changes. Whatever the quantity, the formula stays the same. Yeah, moving on, back to the lesson. 5 raised to 2 times 3, this will be 5 raised to 6. And moreover, if we use 5 raised to 6 in a calculator, we would get 15,625. It really depends. If the teacher asks for an answer this high, an oversimplified answer, this is what we get. But if the teacher only asks an answer like this, then so be it. It depends. If every school has a unique rule, their math teachers have a different perception to the laws of exponents. Finally, we have our last, the negative exponent. One word that we have to remember is the term or the method of reciprocation. We have to remember that we have to reciprocate any number that has a negative exponent. Just like we can derive this term from division of fractions. Example, 1 over 2 divided by 1 over 2. So because of the division sign, we'll have to reciprocate that. That means shifting the place of the denominator will be the numerator and vice versa. So if this is 1 over 2, it will be 2 over 1. And moreover, we'll have our answer of 1. So that's not really our lesson right now, just to remember what we learned back in grade school regarding fractions. Moving back to negative exponent. We do not really have any much of a formula to use for negative exponent, but we can use some examples. Example 1. we have negative 3 over 4 raised to negative 2. Now, because we have a negative exponent, that means we will have to reciprocate. So the denominator will become the numerator, and the numerator will become the denominator. So yeah, this is what we have, and after reciprocating, our negative exponent will be no more. We will change the sign to addition. And if we have this expression now, if we solve that in a calculator, negative 4 over 3 might want to use the calculator while we do this, we would get 16 over 9. Again, our answer varies from teacher to teacher, from school to school. Some answers will be 16 over 9, and some answers would require decimals. So because this answer is a non-terminating decimal, if we see it through in the calculator, that means we just have to apply what's being asked to do. So make the answer correct to 3 significant units and round it off. Round it off to 3 significant figures. There. And I suppose that is all for the laws of exponents. We have a chart. And yes, I suppose the video's done. Thank you.